Okay, we'll resume the session by solving some exercises. So I assume that you solved all these questions. So if you haven't solved it, please stop the video and just try to solve this. Let's go for the first question. Well, compute the determinant of this 2 by 2 matrix. Very easy. So basically we have 2 by 2 matrix. 2, 3, 4, 5. And determinant, you multiply by diagonally, so you get 2 times 5 minus 3 times 4. And what you're going to get is 10 minus 12, which is going to be minus 2. Right? So the end of the game. So that's the answer, minus 2. All right. Now, oh, the number 2 is related to the first one. So we already kind of did this, but I just wanted to make sure that you understand this. So swapping 2 rows of matrices changes the sign of determinant. Remember that we just got minus 2 for this, right? Determinant. Try to swap the 2 row, okay? So you're going to get 4, 5, and 2, 3, like this. And what's the determinant? Multiply by diagonally. 4 times 3 is 12, minus 5 times 2 is 10. You get 2. And you can see that the sign changed from minus 2 to 2. Okay? So that's how you show it. You can kind of show it more abstract, like showing instead of putting a specific number, you can just go A, B, C, D. And you'll also see that the only sign changes if you swap the rows or columns, okay? And we'll solve some Kramer rule, which we didn't talk more about, how to compute it. Although I did tell you about the way to do it. Let's try this with real numbers. All right, so if you want to solve the Kramer's rule, firstly, it's easier to write this in a matrix form, so write it. 1, 2. X and Y, right? So we write X and Y, but this in more abstract term, this is X1 and this should be X2, right? So, well, we'll just go with X and Y. And we have 5, 2. And we'll see how to calculate X and Y. But before we do it using Kramer's rule, let's first solve the equation just hand in hand to see that actually our results are going to be same to the result we get from the Kramer's rule. So if you solve this question hand by hand, you can easily see that it's x plus 2y, 5, 3x minus y is 2. You can kind of see that. Let's just solve it. 7x. Oh, this is going to be a bit complicated question because it's not by integer, right? X this and y is. Am I correct? I'm right? I'm right. Okay. And the y is going to be because it's this. You have y is 35 minus 9. You get. It's really hard to always do simple multiplication for me. 26. So y is, y is going to be 13 over 7. So let's see if the Kramer rule also gets this answer for us. Drink. Okay, let's go. So we'll solve this using Kramer rule for x. So x has to be a division of determinants. With the bottom part, you just do determinant for the matrix here. And upper part is all same, but the first row is going to be changed to 5, 2. So it's going to be 5, 2, 2, minus 1. So what do you get for this? So for the bottom, you get minus 1, minus 6. Okay? And for the upper denominator part, you get minus 5, minus 4. And you get minus 7, minus 9, which is 9 over 7, which was the answer we got already. Okay, so that's correct. Now, let's do it for y. Alright. Everything is same except denominator now changes. Instead of taking out the first column, we take out the second column. So it's 1, 3, and 5, 2 now. Okay? So what do you get? Bottom part, we're still going to get minus 7, right? That doesn't change. Upper part won't change. So what we get is 2 minus 15, which is minus 13. So, and we get 13 over 7 for y. And that's the answer we already got. Y was 13 over 7. So that's the answer. So that's how you use Cramer's rule to solve the problem, okay? So, and even though we did it for a very simple case like 2 by 2 matrices, it all holds for any sort of after matrices. So it holds for like n by n matrices as long as you're talking about squares. So if you encounter more harder questions and if you have to use Cramer's rule or related like determinant solving, don't be alarmed by it. Just do what we just did, like 1 by 1 solutions, like step by step, and you'll be able to get the solution. Okay. So we'll end the exercise here, and we'll have a quick break. And then the next session we'll be going into about eigenvalues, which is going to be almost the end of our session about linear algebra. And yeah, so okay.